We are very glad and honored that Professor Elsberry can visit our university and give us a seminar. Today he will talk about a very interesting topic, which is about the relationship between the global warming and the typhoon intensity. And we are very glad you can come. And in the following, I would like to invite Professor Wang to give us an introduction about Professor Elsberry. Please.
Thank you very much, Chairman Liao. And I met Professor Elsberry when I was in Central Weather Bureau in 1991. So Professor Elsberry has been a long-term typhoon expert to the Central Weather Bureau. I received an email regarding Professor Elsberry's seminars on Monday, yesterday, at the National Taiwan University. So I decided last weekend that we had to do our best to invite him to come here before his return to the US tomorrow early morning. So we are very lucky that you take the trouble to come here. Before his presentations, which is very important and interesting talk, I would like to briefly introduce you to Professor Elsberry. He got his PhD degrees in 1978 from Colorado State University. And after his graduation, he went to the Naval Postgraduate School. And he stayed there since then. So for nearly 30 years. So in that sense, it's very persistent and consistent. And Professor Elsberry is now the chairperson of the WMO Typhoon Expert Group, which is a very distinguished group. And he also won the 2001 Heckmeyer Award. That's a very distinguished award to recognize the contribution of scientists working on the tropical storm research. So today we are very honored to have him to visit us. So let's welcome Professor Elsberry.
Well, thank you very much. It's actually 23 years ago that I first came to National Central University. This is not at all what it looked like 23 years ago. I'm very pleased to have an opportunity to come and speak with you today. My topic is a little bit controversial. And I just wanted to say that at the International Workshop on Tropical Cyclones #6, which was held in San Jose, Costa Rica 2 weeks ago, this was one of the most controversial aspects of our International Workshop. The International Workshop meets every 4 years, and the purpose is to bring together forecasters and researchers interested in tropical cyclones and review what has happened in the last 4 years and look to the future for the next 4 years. Now, the reason we address this topic of global warming and tropical cyclones, my role as the Tropical Cyclone Rapporteur for WMO, as I go to meetings, for example, the Typhoon Committee meeting here in East Asia, or India, or wherever I go, Australia, hurricane conference in that area of the world. One of the things that the heads of the National Meteorological Services ask is, give us some help from you on the research side about how to answer the TV and the radio and the newspaper people when they say, was this tropical cyclone due to global warming? So the purpose of our meeting then, or one of the purposes of our meeting then, was to summarize the present state of knowledge of global warming and tropical cyclones. So my subtitle is, large changes already occurring? That's one side of the people. People say it's already occurring, and other people say it's maybe small changes, but it won't occur for decades, maybe until your grandchildren, okay? So our purpose is to give the heads of meteorological services and the WMO officials how to answer the question, are these tropical cyclone changes due to global warming, or is it something we should expect sometime in the future? So what I'm going to do is just show you how we came to a summary of 10 conclusions, okay? And I can give you, if you want the complete copy of the summary, and then there's 27 points which support that. So what I'm going to do today is simply show you how we came to the summary of conclusions, okay? I want you to say, know though, I am not on this side, and I am not on this side. I am a messenger. So if you don't like what I'm saying, don't shoot me. I'm not the one who's opposite to your view. Okay? So the previous international workshops in tropical cyclones have also dealt with this question of human-caused or anthropogenic climate change. When you hear climate change, it might mean two things. It might mean a natural climate change, or for what many people, if they say global warming, they mean anthropogenic or man-made warming. And so what we're looking for, is there a signal separate from the natural variability of tropical cyclones? Okay? In the previous time that we actually produced a statement, it was in the 1998 Bulletin of the American Meteorological Society. The conclusions at that time were there's little, if any, increase in the number of tropical cyclones around the globe, and there's small, or small means less than 10% increase in the maximum intensity. Okay, so that's what we concluded in 1998. But coming up now is another climate change statement, the IPCC statement, and they're going to say that there's a ½ degree increase in global sea surface temperatures. Okay? We didn't argue that. We're not oceanographers. We're tropical cyclone forecasters and researchers. So we accepted this part, and the basis then of the discussion is, if you accept this temperature anomaly, long-term temperature anomaly, versus time here, notice that in the last 25 or 30 years that there has been this more rapid increase in global sea surface temperature. And the magnitude is about ½ degree. Okay? So we accepted this. We did argue this. Even Bill Gray, for all he argues about global climate change, even he didn't argue about that. So what caused the controversy? The controversy began when Professor Carey Emanuel from the Massachusetts Institute of Technology published a paper in 2005 and said that there is a substantial increase in the power. Now what he did is take the 6-hourly wind speeds, maximum wind speeds of all tropical cyclones, and so power is a summary of the whole length of the duration of the tropical cyclone, and then cubing the maximum wind each 6 hours. So that's the power. In other words, that's the amount of dissipation of energy that has to take place. Now, I'm sure all of you have taken a physics course in the physics lab, and you've calculated the uncertainty. You make a certain measurement, and then you say there's a certain uncertainty. And you know that if you take a 90-knot storm and you cube that, but there's an uncertainty of 10 knots and it's really 100 knots, or if it's really 80 knots, and you cube that, you're going to get a very big difference, right? And so how well do we have to know the tropical cyclone maximum intensity in order to get a good value of the cube of the total amount of energy or total amount of power in the tropical cyclones? So specifically in the Atlantic and the western North Pacific, where you people live, in the last 50 years, he says there's been a substantial increase in the power. So here's his curve. This is then the measure of power, and this runs from 1930 to 2005. And the solid line here is the sea surface temperature as estimated by the Hadley Center in a particular area. This area from 6 to 18 degrees north and from 20 to 60 degrees west is what we call the main development region for Atlantic tropical cyclones. It's an area that's west of Africa. African waves come off of there, and it's the favorite tropical cyclone or Atlantic hurricane development area. So that's the sea surface temperature, and then the power dissipation index, that's from Professor Emanuel. You can see that, especially recently, there's a very nice correlation with that. Okay? However, another player in this is Dr. Chris Lancy from the National Hurricane Center in the United States. And he's been a leader of a project, I don't know if you can see it in the back of the room, but down here is from 1949 to 2005 is the reanalysis. They've gone back, they've gone to ship logs, they've gone to newspaper accounts to try and get the best possible estimate of the numbers and intensities of tropical cyclones. So this is probably the best analysis of tropical cyclone activity in the world, just because of this 15-year reanalysis project. And so if you now look at his modification of the power index, you'll see that there have been significant variations in this power index over the years. And instead of going up so strongly here at the end, it only goes up a little bit, not too much different than what it's been in the past. And we've had two very active years in the Atlantic, but in 2006, which is not plotted in here, the power index is probably way down here. So when you average over 5 years, this curve now is going to come down. Okay? So, that's the first questioning of Kerry Emanuel's statement that there's been a substantial increase in tropical cyclones power. The second paper was by Webster, Greg Pollan, Peter Webster, Greg Pollan, Judy Curry, and what they also say, substantial, meaning nearly 100% increase throughout the globe now, not just the Atlantic and Western North Pacific, but throughout the globe, that there's more Category 4 and Category 5 on a scale of 5. There's more Category 4s and 5s than there has been in the past, and a decrease in the number of weaker systems. So what they're saying is the total number of storms is the same, but they're getting more intense. Fewer of the weak ones, more of the more intense ones. So here's their curve. On this side is number of hurricanes of different categories, and this is from the mid-1970s to 2004. And the curve you want you to look at is the red one here. Category 4-5 storms is starting at around 40 and ending here somewhere around 90. And so what they're saying is there's been almost, more than a doubling of the number of most intense tropical cyclones. The reason that's important is because the damage from tropical cyclones goes up with at least the cube of the maximum wind, and maybe the fourth power of the maximum wind. So these are the most important ones. And so if there are more of them, we can expect more damage, right? That's our next statement. Is the increase in economic losses due to global warming? Okay? Certainly in the United States, we've had much increased economic damage and disruption of our economy in the United States. In fact, I was in Perth, Australia last year after Hurricane Katrina hit in the Gulf of Mexico and created so much damage in our city of New Orleans, but it also disrupted the production of oil in our major oil-producing area of the United States. And I was in Perth, Australia, which is about as far away from New Orleans as you can get. But my friend there said the first day after Hurricane Katrina, the gasoline prices in Perth, Australia started going up. They were going up so fast that they had to pass a rule that they couldn't raise the prices more than once a day. They were only going to raise it once a day. So Hurricane Katrina, because of its effect on oil production, affected the whole world. Well, I'm assuming the whole world, but so this is a global problem. But we also know, and I think this is maybe also true here in Taiwan, that we're getting more and more people who want to live on the coast, and there's more and more industry on the coast. In the United States, that means there's a lot more people, a lot more insured houses, insured businesses, and so forth. And in the United States, the National Hurricane Center, the way they get their first order estimate of hurricane damage is they go to the insurance companies. The insurance companies all say, we had to pay this much out for repair of the damages in this hurricane. And then they double that and say that's the amount of damage. So whenever the insured values go up on the coast, the likelihood, the vulnerability, the risk goes up. So if you just plot total losses, the total losses are going up very fast. But if you take into account the increasing population, the increasing of wealth, in other words, building more expensive buildings, putting more businesses on the coast and so forth, and also the sensitivity of our economy to disruption now. We're much more sensitive to any kind of disruption, loss of power, our computers don't work, there's nothing we can do, we can't play computer games, so our lives are really bothered by this. All this sensitivity, if you take into account all of these factors, what Chris Lancy, when he looked back in history, he found that the storms of equivalent, if you normalize by the losses, we've had storms like this in the past, like Katrina. There wasn't very much economic damage at that time, but if you take into account the fact that there's much more people at risk, there's no evidence that, no strong trend in normalized economic losses that you can detect over the last 100 years. Okay? So, in the United States and Japan, and my guess is also in Taiwan here, the number of losses of life, the number of deaths caused by typhoons is probably going down. But that's only in the developed countries. In those countries that are still developing and you've got people that are very vulnerable and unable to move away from the coast when a tropical cyclone comes, I'm afraid that we still have to expect that we're going to find disastrous losses in developing countries. So our conclusion number 3, I'm going to save conclusions 1 and 2 until I get to the end. Conclusion number 3 is the recent increases in the societal impacts from tropical cyclones has been largely caused by the fact that we're concentrating population and infrastructure in these coastal areas. We cannot attribute this to global warming. Okay? Now, another thing which Chris Lancy's done is to look back and see in the Atlantic area, did we count all the tropical cyclones? Is it, in other words, are these greater numbers of intense storms because we're better able to measure them? Okay? And so, if you compare, as Chris Lancy did, this is our 2005 season. We had 28 storms. It broke the record by 5, okay? And the normal is of the order of 12. So we had more than double the number of tropical storms and hurricanes in 2005. And notice the tracks. We even had a storm hit Spain. I think probably for the first time in the records. But if you go back to the 1933, which is the closest number of tropical storms as we had in 2005, look at the tracks. Notice where all the tracks are. Gulf of Mexico, Caribbean, Western Atlantic. Notice how many are out here. Is that because they didn't exist in 1933? Or is it because we just didn't have anybody out there measuring it? The satellite coverage really wasn't very good back in 1933. You're too young to know that. So what Chris Lancy's done is go back and just highlight those cases. The ones that are in green are the ones that are, struck land. This goes back to 1900. Okay, but he's also had the ones which are on the open ocean and may not have been detected. If you then look at those, then look at, we had all of this activity, which you might have thought we didn't have much activity there if you only counted the ones that were over land. And then all of a sudden, we've got all this activity. Well, the other thing, we now have satellites. If you look and count, as Chris Lancy did, in the satellite era since the late 60s to 2005, if you look at the percentage of tropical cyclones detected by satellites, and I submit to you that I don't think we miss a single tropical cyclone anymore. I think our goal satellite coverage is we never miss a one. Okay? If you look at that record, 58% of them strike land. But if you go back in the historical record and say how many of them struck land before the satellite era, you find 77%. Okay? Do you think there's any difference in tropical cyclones here and here? No, it's because we just didn't know that they were out there in the open ocean. Okay? So, the first questions or counter-arguments to the controversial arguments have been on the basis of tropical cyclone data reliability. And what Chris Lancy is saying is we've probably missed a lot of tropical cyclones, even in the Atlantic, where we've got probably the best record. Another thing which Chris pointed out, he went back and interviewed the weather people who flew with the first reconnaissance planes. The first reconnaissance came when some foolish pilot went out and flew into the center of a hurricane. Wasn't supposed to, but he came back and said, I made it. Okay. But what Chris found when he talked to these people who flew with the Navy and with the Air Force in the Atlantic, what he found out is that they would, if they were flying at night and if they were thinking that this is a very intense storm, instead of going all the way to the middle, they had an aircraft radar that they could fix the position. The main thing that they had to do was find out where it was, not necessarily how intense it was. And so they would miss it. They wouldn't even go into the center to find out what the central pressure was or what the maximum wind was. And even when I was flying, I hate to tell you how many years ago that was, what I noticed is we didn't go straight into the eye. The pilots would be looking at their little surveillance radar in front of them. If there was any hard radar echoes in front of them, we'd go like this. We wouldn't go directly across the radar echo, we would go around it, which means we would miss the strongest winds. So that's what Chris found. In all likelihood, the early aircraft reconnaissance is not like it is today, where they go just right through and will hit any maximum wind. Well, the other thing, where do we get our information about intensities in all the other areas except the Atlantic? We get it from satellite coverage. Okay, and the Dvorak, keep doing that. The Dvorak technique has changed as the satellites have got better resolution. We've got better techniques for inferring the intensity of tropical cyclones from satellites. So Phil Klotzbach from Bill Gray's group. He went back and looked over the whole globe, only since the 1980s, when our satellites have been sort of the same quality. And he found, at most, less than about 10% increase in the global number of tropical cyclones. So this directly contradicts what Webster et al. Said. They said 100% increase. Platzbach was saying 10% at most. Okay? But the real clincher at the International Workshop was this study by Cosin et al. What they did is degrade our present satellites back to the coverage or quality of satellites in the 1980s. So they didn't use our best satellites. They degraded it back to like 8-kilometer resolution, whatever they did, to get the equivalent satellite coverage over the whole globe, reanalyze every tropical cyclone over the whole globe since 1983. So the red curve here for the Atlantic, the red curve is the one going up and down like that. That is what's called a hurricane data record. That's this reanalysis that's been done by very carefully to see what the total number and intensities of tropical cyclones is. This happens to be plotted as the square of the maximum wind speed, but it's kinetic energy. So what you see is similar in the new record from the University of Wisconsin. That's where Cosin is. The new record agrees with the record that Webster et al. Used and shows from the mid-80s, it shows in fact that there is indeed more intense tropical cyclones since 1980 than before. And if we go to the Eastern Pacific, we see a very good correlation with the old record that was used by Webster et al., but we see it's going down, not up. Okay? So at least here, the careful satellite reanalysis agrees with the records that Webster et al. Used. But if you go to out here, Western North Pacific, where 1/3 of all of the tropical cyclones in the world exist, the curve from the Joint Typhoon Warning Center is this one, and it shows an increase in the amount of kinetic energy in the Western North Pacific. But if you go to the reanalysis, the trend line is opposite. The trend line is for fewer intense storms, not more intense storms. If you go to the North Indian Ocean, there aren't many storms in the North Indian Ocean. The old record shows an increase, the new record shows a decrease. And the farther back you go, the worse the discrepancy between the two records. And then that's true in the Southern Indian Ocean. Oh, they have quite a few storms in the South Pacific. In other words, the records, the new carefully analyzed satellite record disputes completely the statement by Webster et al. That there's been a 100% increase in the most intense storms. Okay? This was a blockbuster slide for most people. This is what really convinced a lot of people that the controversial paper, there's no basis for their statement. Okay? So that brings us to conclusion number 4. It's a very weak conclusion, which could be written much more strongly, but what it says, and I'm only reporting what they said, I'm not saying, I shouldn't be saying anything more than what they're saying. Tropical cyclone wind speed monitoring has changed, the satellite techniques have changed, and so forth. And that's why we have a very difficult time to determine what the trend is. It's certainly not 100%, but what is it? Is it natural variability, or is it man-made global warming? The other thing, is it really, if you look only from the mid-70s to 2005, is that a long enough record to say that it's a man-made trend? Now that's when the sea surface temperatures did increase. What what Professor Johnny Chan from the Hong Kong City University showed, he went back earlier in the record, into the late 40s and into the 1950s. And what he found is that there's been an increase in the 50s, a decrease in the 70s, and we're back up. We're back up to higher values. So that's what's called a multidecadal signature. So what he found is that there's yes, there's an increase at the end maybe, but that's because it's previously been down, and now it's coming back up. Okay? And Stan Goldenberg and his colleagues have said exactly the same in the Atlantic. In other words, their explanation for what Webster and Emanuel found was that it's all part of a natural variability. A natural variability where we were really down in the 1970s and 80s in the numbers of tropical cyclones. And since 95, we've been way up in the Atlantic. But according to Goldenberg, that's just part of the natural variability, not man-made. Okay? But Kerry Emanuel didn't take that lying down. His colleague went out and said, no, there's no multidecadal oscillation that can account for the sea surface temperature, or this change in numbers of tropical cyclones. In fact, it must be due to solar activity, volcanic and man-made aerosols, and the greenhouse gases. So this is where the controversy is, as to whether or not there's another explanation for the variations in the Atlantic. So this is the return of Emanuel. They went even farther back. I don't know if there's any ocean. This is, again, the sea surface temperature is the blue. That's appropriate color for sea surface temperature. I don't know if there's any oceanographers in the audience, but when I gave this talk last week in Monterey, where I'm from, we had a lot of oceanographers there. And they're not very confident about sea surface temperature records like this in the 1860s. I don't know how they would go out and measure. Maybe they threw a wooden bucket off of the side of the ship and measured sea surface temperature there. I don't know how they did it. Their satellites weren't very good in those days either. But nevertheless, the conclusion number 5 here is that there is a multidecadal variability in tropical cyclones in some regions, particularly the western North Pacific and the Atlantic. But the causes of that, we cannot, according to our statement, we can't determine whether it's natural, whether it's anthropogenic, or a combination of the two. So that we're still debating that one. But what it says is there's such a large multidecadal variability, it's hard to detect a linear trend of that. Right? Now, another counter-argument has been on the basis that we have a certain theory of what the increase in intensity of tropical cyclones should be for every degree of sea surface temperature. How much of an increase did our theory tell us before these controversial arguments? So what Tom Knudsen and Bob Talea did, the GFDL model is one of the best hurricane models. And what they did is go back into the climate models where they double the CO2 and run the climate model over 80 or 100 years with associated greenhouse warming. And what they did is take the resulting tropical temperature profile and moisture profile, put it in the regional model, uniform values of temperature and humidity over the whole area, start a hurricane, and see how strong that hurricane was. So in the new atmosphere, in new climate, what would be the strength of the tropical cyclones? So what was the answer? So this diagram here, on the bottom scale is minimum sea level pressure. So the more intense storm is to the left, not to the right. Okay, so this is category 3, category 4, category 5. And what is shown here is a control with the present numbers of tropical cyclones. So the area under the curve is the numbers of Category 3, Category 4, Category 5 tropical cyclones in the control. And the solid line is if you double the CO2 in that new atmosphere from the he used 9 different general circulation models or climate models. They used 3 different tropical cyclone basins, and they used an ensemble approach so that they average a number of different GCM atmospheres and a number of different basins, and this is the answer they got. What you should look at is just the fact that this whole curve is shifted to the left. It's shifted to more intense tropical cyclones. The areas under the curve look like they're about the same. So the total number of storms may be the same, but according to this model, it's more likely that they're going to be more intense. Okay? So this leads us to conclusion number 6. It's likely that some increase in the peak wind speed is going to occur. The magnitude is 3% to 5% increase for every 1 degree sea surface temperature. So remember my early sea surface temperature plot? It had a ½ degree increase. So what we would expect from that ½ degree increase is a 1.5 to 2.5% increase in intensity. Well, if you look at the Webster paper, they're saying there's already a 5 times larger increase in intensity than our best model would say. The Emmanuel is even worse. They would suggest that the storms are already 8 times as large as our theory would suggest. Even Kerry Emanuel's theory in 2004 did not explain these kinds of numbers. Okay? So it doesn't agree with our theory, and so conclusion number 7 is it's inconsistent with our present understanding of the theory, that we would get such large values of increase so early already. Okay, and finally, will we get more of them? Okay, will we get more tropical cyclones? And then perhaps also more intense. So the material that was presented to us was on using medium to high resolution climate models. They're actually suggesting, and I'll show you a very complex table, I'm just telling you the answer already. The answer from the climate models is we're going to get fewer tropical cyclones, not more. Now, some regions are going to get more, and some are going to get less, but overall, on the global view, we're going to get less. Okay? So what you want to know is in the Western North Pacific, are you going to get more, or are you going to get less, right? Okay, so look at this column here, Western North Pacific. And over here are the different global models. T105 JMA, Japan Meteorological Agency. This is the NCAR model, the Hadley Center model. This one, I'm not sure what that is. Here's another JMA model. This is in Europe. And finally, the highest resolution model, climate model that's been used to study the number of tropical cyclones is this one from MRI, Meteorological Research Institute. And so if you look in the Western North Pacific here, the blue numbers are fewer tropical cyclones than in the control. And so you see either no color, or I mean black, or all blues here in the Western North Pacific. You're safe. You're less at risk than if you believe this. Okay. So your insurance rate should not go up so much. But if you look at the Atlantic, at least one of the models says that they're going to get 160% of, control. And so in the Japanese model say 134%. In other words, the ratio of the number of tropical storms to the number in the control experiment is an increase in this area in the Atlantic. There's also an increase here in the Eastern Pacific for two of the basins. But overall, if you look at the overall summary, you'll see a lot more blue than you do red. So the conclusion down here at the bottom is that there are fewer tropical cyclones globally in future climate simulations. Okay? Although there'll be regional changes. That brings us to a caveat or a qualifying statement is, should we really believe these coarse resolution climate models if we're going to count the number of tropical cyclones? Bill Gray says, with a very strong voice, no, we can't forecast for a week, 2 weeks. How can we forecast for 100 years? But at any rate, that's Bill Gray. Some people are certainly questioning whether or not the cyclogenesis process in a coarse resolution global circulation model is the same thing as in nature. Okay. So we might expect that, that cyclogenesis process might be different. So conclusion number 8, although there's been, the recent climate models say fewer or no change in a warmer climate, there's pretty low confidence in this. And in particular, the uncertainty is whether or not the tracks are going to change. To me, that's the most important question. In the Atlantic, if it wasn't for the shift, the westward shift of the tracks in recent years, so that all these storms are hitting the United States, we wouldn't care if Katrina was out there east of the United States. Well, we'd kill a few fish, but other than that, we wouldn't really care. It's because they're hitting land that we care. Okay? So I think the most important question is there going to be a circulation shift where land areas are going to be hit by more storms or more intense storms? All right, so this brings us to the bottom line or the conclusions of our study. So conclusion number 1, there's evidence both for and against the existence of a detectable anthropogenic signal in tropical cyclone climates to record, but we could make no conclusion that there is evidence for an anthropogenic increase in the number of tropical and intensity of tropical storms. In other words, so far the counter-arguments that have come out this year in response to the last year's controversial articles, it seems like the counter-arguments have won over and disputed the conclusions of they do not support the conclusions of those previous studies. And the statements that have really bothered me the most, specifically after Hurricane Katrina, when a certain well-known climate scientist, who happens to be the chairman of this IPCC climate change thing, was going to make the next assessment, came out and said that 7% of the precipitation in Hurricane Katrina was due to global warming. Not 8%, not 6%, but 7%. And what we're saying is no individual tropical cyclone can be directly related to global climate change. Now, everything up here and everything I've shown you so far is directly out of the summary. It's not my statement, it's the statement of the International Workshop. So here's my statement. My statement is, given our present understanding of our theory and of our numerical modeling of the impact, and the fact that we've only had a quarter or to half a degree increase in sea surface temperature in our tropical sea surfaces, tropical oceans, and given our present ability to observe the winds and the precipitation in tropical cyclones, We only report it to the nearest 5 knots, okay? How well can we measure the precipitation of tropical cyclone? I challenge you to go out the next typhoon that comes by Taiwan, take your rain gauge out there, and try and measure the precipitation accurately when the winds are blowing that way at 100 knots. Okay? You're not going to get a very good rainfall measurement, and our radar calibration isn't probably so hot either. So what I'm saying is that we only have a certain capability to measure winds and precipitation, that we cannot attribute any unusual wind or precipitation in an individual tropical cyclone cannot be attributed to global warming. This is what I think the heads of the meteorological services want. They want to be able to say to the media that we have no evidence that the storm that is hitting this country at this time is due to global warming. That's what they want to be able to say. But I think my statement is better than their statement, at any rate. And I particularly want to say that it's incorrect to say that 7% of rainfall is due to global warming. So why should we worry about this? Well, I don't want you to go away from here and conclude that there aren't natural variability. We may have trouble detecting man-made effects, but there's definitely natural variability. There are unusual tropical cyclones happening. We detected the first tropical hurricane in the South Atlantic ever. That's unusual. We have this multi-decadal variability in tropical cyclones here in the western North Pacific. We have it in the Atlantic. We don't understand why. We need to understand that. We need to understand the natural variability before we can understand the man-made variability. And something like the El Nino, Southern Oscillation, which has such a strong effect on Atlantic activity, doesn't affect the western North Pacific. It shifts things in the western North Pacific. Doesn't change the number so much. But in the Atlantic, it really can, El Nino really can slow down or decrease the number of storms. So we need to know more about natural variability, interannual, multi-decadal, and why these unusual storms are happening, and not jump to the conclusion that it's global warming. Finally, unfortunately, I could not get a slide or PowerPoint from Greg Holland. The last thing he showed before he had to leave the meeting was a diagram sort of from that increasing sea surface temperature. And he said, we really need to know whether or not that's going to go like this, whether it's going to level off, or whether we just hit a peak and we're going to go down. Before about a month ago, we had a fellow from the Geophysical Fluid Dynamics Laboratory named George Philander, come talk with us at Naval Postgraduate School where I'm at. And he looked at the geological record and said, we've had sea surface temperatures going up and down in the geological record like this, just like we have had. And that wasn't due to man-made effects. And he made a kind of off-the-cuff remark that said, well, we could be going into the next ice age. And the fact that we've got all this anthropogenic warming is keeping us going from the ice age. So, could be going this way, could be going that way, or we may be going into the ice age. Bill Gray says we're going to go back down. So maybe in your lifetime, you'll see that we're going to start talking about nuclear winter again instead of global warming. But the conclusion is that at the present time, our records of tropical cyclone intensity are not, or precipitation, are not adequate to detect a man-made effect of global warming on tropical cyclone intensity. that's my conclusion. I'd be happy to answer any questions.
Thank you very much. Any question and comment? Thank you for those important and interesting messages.
Okay.
That's a very nice comprehensive summary. So I kind of curious, what is the status, the assessment report number 4, IPCC World Tech, because it's coming out very soon. And for the previous 2 years, I noticed the Webster's conclusion and Emmanuel conclusion. I think the global change community already accept that kind of the statement. So I'm kind of curious, what would be the assessment report number 4 World Tech on these issues?
We're hoping that our statement will go to the committee, subcommittee, the IPCC, and change that conclusion. That's what we're hopeful. The reason I am concerned, and other people at the meeting are concerned, is the chair of that subcommittee is the person who said 7% is due to global warming.
I was in the IFA meeting and some of the ESSP meeting, Earth System Science Partnership. I think the Global Carbon Project and Global CWSP project, all the projects always cite Emmanuel's, I think Webster's paper, the category 4 and 5 is increased many percent, and then used as a very fundamental argument for the existence of the increase of the frequency.
And the Cosin slide, the Cosin study has just killed that. It's really said that is not true. To me, when I saw that transparency, that changed everything for my point of view. It's the most careful study of the satellite data over the whole globe, and it disputes the record. The only thing is the Atlantic is going up, but the explanation from Bill Gray and others, Chris Lansing, is that's just part of the cycle. That's part of the multi-decadal thing, and you should not make a conclusion based on that short of a record.
Yeah.
Did any of the climate model taken into consideration of feedbacks, or just the one that's the business as usual?
The problem is, these are all coupled models, coupled to the ocean. But what I think you're asking is the cooling of the ocean due to the passage of the tropical cyclone feeding back into it? The problem is, in a coarse resolution climate model, you don't get a structure that looks, the so-called tropical cyclones are much weaker, therefore they're not picking up the heat in the same area or cooling the ocean in the same way. Because that's going to go up with the velocity. And the exchange coefficient is dependent on the velocity. For sure, the coupling with the ocean is not correct.
Ross, you showed that diagram about the future hurricane frequencies. Can you go back? Yeah, it's very interesting to see the red numbers all very big, but blue numbers are kind of minor. You know why? And then the second question, this is for future, right? And then you use the same model to run tests, see how well they did for their modeling, so they can at least convince people how good they are talking about future.
That's a good suggestion. Yeah, what you're saying is, what's the veracity of these various models here? If they would go back in the record and try and reproduce our better record of the numbers of tropical cyclones. To my knowledge, that has not been done. But that's certainly an excellent suggestion.
Any more questions?
Okay, so don't believe everything that you read about global warming and tropical cyclones. Thank you very much for the opportunity to be with you.
Thank you.